Let's take a look at 110.16, arc flash hazard warning. Requirements for arc flash warnings, markings increase. Again, this is every time it's going on, they keep modifying rules, and the title was revised. All right, let's take a look at it. The title first. It says arc flash hazard warning. I don't remember what it used to say before. Anybody remember what it was?
Flash protection.
Flash protection. Okay, well, now we're talking about arc flash hazard warning. And then the requirements are electrical equipment in other than dwelling units, little editorial change, which may be worked on or examined while energized, require a field mark arc flash hazard warning sign. So, Ryan, that's the only change that was made there, basically?
Well, and it's subtle.
So I was going to say, that's just like, oh, well, why are you covering it? It's a little tiny, what, one word?
Well, what it used to say is electrical equipment such as blah, 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 in other than dwelling occupancies.
Oh.
So when you take, for example, a multifamily dwelling, an apartment house, previously, that is, in fact, a dwelling occupancy. So you could have a 1,200 amp, 480 volt service on a multifamily dwelling with no arc flash sign.
Hey, no, it's not a dwelling occupancy.
Exactly. Yeah.
I mean,
so
it's
now it's other than dwelling units, and it would be nice if it said individual dwelling units, but I think it's the same thing. So inside my apartment, I don't need to have the arc flash warning. But when I go outside of my apartment and I've got a 1,200 amp, 480 volt service, obviously that could blow up. So you know,
right here on this graphic, then, I could put this on dwelling unit 1,
right,
dwelling unit 2, dwelling unit 3, dwelling unit 4, 5, 6, or, well, of course, it's three-phase, so I can't do that. But, okay, in this case, I couldn't. All right, so we now, and I appreciate you bringing that, okay, it's dwelling units, not dwelling occupancies.
Right.
Now, let's get into the details. Why am I bringing this up? Because it's a, insignificant change. Well, what kind of label? Now, this is a field, let's read this again. Requires a field marked arc flash hazard warning sign. This is field, not by the manufacturer. Well, you know what? Here's an example from, I think, Cutler Hammer. It might change, but this is the last time I've seen this. And they'll give you labels. Electric arc flash hazard will cause severe industry, because if you go back to the rule, it didn't tell you what's on the label. It didn't tell you how to make the label. It just say, hey, you need a label on there. So manufacturer gives you a label. Here's electrical contractor. He said, you know what? How about if I put my logo on there? And, funny, I got this from somebody. I did a seminar. A guy said to me, was that I got it from you? Yeah. I did a seminar. A guy came up to me and goes, hey, that's my label.
Oh, is that right? Yeah, Dirk Burton.
Yeah, so Ryan, you gave me the image. I used it in a seminar. A guy said, that's my seminar. That's mine. So that was really cool. I guess it was in the Northwest somewhere there. Yeah. All right. Now, what kind of label should we have? Well, NFPA 70E, let me describe it, Standard for Electrical Safety in the Workplace, gives information about creating an arc flash warning or arc flash hazard label. And it gives you details on how to calculate things and what's going on here. We'll talk about that in a second. This would be an example of a label that probably would be generated by using the calculations or the requirements in 70E, giving information to the person working on that, such as line side of the main, load side of the main, the flash protection boundary, the hazard risk category, the incident energy, the calories at centimeter squared at 18 inches. I mean, that's your calories. Then, of course, it goes to the load side as well. And I'm not sure, that's a KVA. It's a study. This is done by an engineering firm through some specific software that they use that. Eric, do you guys do arc flash warning labels? You have software with Dow Chemical. I mean,
right.
Is that something you guys, is this?
Yes, we do. We model our systems in a software. Can I mention the name of the software?
Sure, absolutely.
Okay, the name of the software is ETAP, and the systems are in ETAP. And when you put in all the upstream information as much as you can, and the KVA rating of the transformers and the cable impedances, then you get some. You can get short circuit currents.
And then the time of the protection device.
The time of protection, the calories at every point downstream that you want to pick.
Okay, listen, you're an electrician. What the heck am I supposed to do? Well, you get a label from somebody, and you put on the code, and you put on the label. You're like, hey, I took care of the code. Now, if something happens, somebody gets hurt because the label didn't give enough information, and then you didn't comply with 70E, now you have to deal with OSHA. But when does OSHA get involved? OSHA gets involved after somebody got hurt, not before somebody gets hurt, only when somebody gets hurt. Not only that, but if you get a label like this, take a look at the label. What the heck does this mean to 99% of the electricians? They don't understand what this means. We need to have education. Let's take a look at, well, calories. I don't know but where it's marked on here, but this is flame retardant clothing, okay? Personal protective equipment. This jacket is, these shirts are, and they're made to comply with a certain calories. Look, the instant energy is 4 to 8 calories. So you need to have something that would be for 8 calories. It's a pretty broad range saying 4 to 8, but it makes sense because of time curves. So you need to have something. So if you're going to put on a shirt to work on that, or gloves and face shield and helmet, it needs to manage that specific, flame retardant resistant. Eric?
The other thing, Mike, is that if you have a large facility and you do all these calculations, what you're going to find is all different calorie ratings at different facilities. And so you don't want to have a whole closet of clothing with you. You say, well, I want a 20-calorie suit here, 50-calorie suit here. And so, for example, at Dow Chemical, at least in our Freeport facility in Texas, we have standardized on 50-calorie because that's worst-case scenario. And when you are required to put on a flash suit, well, then that's the one you put on.
All right, now, hold on. Look at this slide now. Is this like a 50?
A 50 calorie. That one could be by looking. Now the gloves might be 100 calorie. They might have a.
So basically, I got to put on a spacesuit to measure the voltage inside this 120 volt panel at Dow Chemical, only because we don't want to have a 1 calorie, a 4, an 8, a 12, a 20, a 50. Listen, anytime you're going to work on something, then you need to make sure you have the right protect. Now, let's understand something. 70E says you cannot work on anything that is energized. Cannot. Here's how this whole thing is supposed to work out. You see this bunny suit you're putting inside here with the gloves and the whole deal? And you're going to go to that equipment right there? What you do is you put that whole suit on, then you open, first of all, you turn it off. Okay, let's try it again. You put your suit on. You turn it off because it might explode when you turn it off. Then you open it up. Then you get your voltmeter. Then you go check to make sure that, of course, then you lock it and you tag it. Then you, with your suit on, then you go check everything. There is no voltage. Now, you can take your suit off. Now you can work on it. You are not supposed to say, oh, I need to have an 8 calorie. So let me go get an 8 calorie and put that on there. And now let me go ahead and now remove the breaker and replace the breaker in an enclosure. You cannot work on anything hot, period, ever. Now there is some exceptions inside here. And it's where like, if you don't work on it hot, it's going to make it more dangerous. And I can't think of a scenario that it's safer to work something hotter, because if you didn't, it would make it. But I guess there can be some. So there. Plus, you have to have it written. You have to have it signed. You got to get everybody to sign to agree. Listen, you're an electrician. I don't care how much knowledge you have. You don't work on it hot. Now, I understand, Mike, the switch and the receptacle, and Mike, come on, be realistically here and that. But you know what? Even the switch and receptacle, all you guys have changed switch and receptacles, having to work. All you guys are journeyman electricians. I know that, master electricians. All you guys for working in the field. All you guys are licensed and instructors and teachers and all that. And we haven't been physically doing work for a long time. But when I change a 3-way switch or something in my house, or a single pole switch or a receptacle, in the past, until recently, I didn't turn off the breaker. My wife is like, don't you think you should turn off the power? You know how women are. You know, they're just too smart. You know what I mean? We're like, hey, Mike Holt, I've done this stuff. I know what I'm doing here. No big deal. But then I get shocked. And I'm like, so I buy the little tiny thing, put it on my head, go turn off the breaker. I work on the switch or the receptacle. I think there was a switch. And I was like, I wasn't afraid. I wasn't like, let me, you know, guys, know what I'm talking about? It went faster, it was more efficient. I thought, what an idiot I was all those years to work on something hot, even changing a switch. There's no reason to have anything hot to do anything. Buy the little thing with LED at Lowe's or Home Depot for $20. Stick that in your toolbox. Go there, turn off the power, work on that. Never work on it hot. We don't need the danger. Let's talk about what could happen if you did work on something. Well, here's just a picture. I think this is from Busman Fuse. It's like a little video clip or something like that. Guy, this is all NEC compliant installation. So if you do it according to the code and you take a screwdriver and you make a mistake, you can have an arc, flash, as well as a blast. Now you can see this copper molded metal. Now in this graphic, this is real. You can see the hard hats down here. You can see, imagine somebody being physically between the two locations. This is a photo of one of the guys. I think there's two guys, and I have the photos of their faces, which I really don't think I need to show right now. And imagine the guy that was standing in front of that meter, or the guy that was standing in front of that disconnect, or the guy that was just putting in the cover, the guy just plugging in a meter. None of these guys thought any of these incidents was going to create a major problem. I want to show a videotape about an arc blast. And John, did you want to say something before I show this videotape?
Yeah, I did. NFPA 70E has a handbook that goes along with it that has some explanatory material on what goes on during an arc flash. Just so that you know, temperatures in excess of 35,000 degrees Fahrenheit, a blinding light that can take out your eyesight, the concussion can puncture your eardrums, let alone blow you away from that area. None of these things are good to a human being. So what you're going to see in this video is going to explain a lot of that and some of the serious injuries that go on during an arc flash.
All right, let's go ahead and I'll play this video. Now there's three, let me just kind of set the stage. There's one guy that's inside the enclosure, one guy standing here, another guy standing on the outside. This guy here, I'm about 150 pounds. This guy looks like he's bigger and stronger than me. He has to be probably 200 pounds. Watch about the arc blast, not the arc flash, that's the light, the arc blast. What happens to this guy physically? All right, I'm going to stop it for a second. There's your arc flash. That is going to create an arc blast. So you can see how far he was thrown. I don't know, 15, 20 feet. This guy, he got knocked out this way, and the guy that was physically inside here, you can see where he's at. He couldn't get blown up and out. He just got blown down and out. I don't think we have to go any further than that. I think it kind of tells the story. Here's another video. I'm going to go ahead and pause this for a second. Actually, no, I'm going to run this one at full screen at full speed. This is real-time speed. The other one was just half speed, just to kind of show you what happens on. Now, they happen to have a camera in this room at the time the guys were putting in a breaker. And you can see he's cranking it. Now, Eric, what's he doing with that breaker? He's cranking it in? How does that work out?
It's ratcheting it in.
He's ratcheting it in.
Yeah, he's ratcheting it in to where it's on wheels, and then a thread pulls the breaker in and engages the contacts.
This is half speed.
Now, he doesn't expect his life to be changing forever at this moment. That's real time. That's how long this blast is taking place.
Mike, this is also a good reason why a lot of the breakers now are being remotely racked. Mm-hmm. You put up equipment to the breaker and have an umbilical cord. When you press the button, you can stand away from it, and the equipment in front of the breaker racks the breaker in.
Oh, nice.
All right, let's go back here. NFPA 70E gives us the information how to calculate the proper protective equipment to use and how to deal with the situation. But understand, the calculations based upon this is assuming that it's a bolted fault with the worst possible case, the lowest amount of impedance, and the protected device has a certain amount of trip time for that bolted condition, and therefore it does the calculation. This is the energy, the incident energy, and this is the clothing that you could use. Well, it's highly likely that the fault is not going to be a bolted fault. It's going to take longer than what's projected, and the amount of energy, the incident energy, is going to be greater. I've been involved in too many court cases of guys that have been killed, or the worst case scenario is actually you go through a condition like that, what we've seen in that one video, and you survive. Imagine a man. He's burned. He can't work anymore. He has no fingers. He's totally disfigured. He doesn't have the capability of producing for his family. He sits home and watches what? Soaps? I mean, this is the case studies that I'm involved in. I mean, the person, it's a terrible thing. Why? You don't quit your job, go somewhere else, don't get involved, don't work it hot, go work at McDonald's at $8 an hour, live in a smaller house, don't get a brand new car, don't worry about a boat. Have a great life. It isn't worth it for you to take a risk for anybody.